Hey, Matt. It's good to see you.
Welcome to Chaos Carnival 2023. We'll let people join and we'll get started here shortly. It looks like we have about 1,600 people registering for this event right now, and a bunch of people are logging in. So this is great to see everybody from all over the world. So,
Really cool,
yeah. How did you start your day today? What kind of breakfast did you have, Adrian?
Don't really have breakfast in the morning until I'm done walking the dog. So every morning I have a dog, and every morning I do about an hour walk by the sea. And now the snow was melting, so it was more like a ice walking rather than anything else. But luckily I didn't break a leg, which is good.
Yeah. No, it's awesome. You and I both have dogs. I live in Minnesota in the United States, and you're over in Finland, so our weather's kind of the same and everything. But cool. All right, well, we're going to get started here, and then we'll get rock and rolling for that. So good morning, good afternoon, good evening to everyone around the world. Welcome to Chaos Carnival 2023, brought to you by Harness. My name is Matt Schillerstrom, and I'm a product marketing manager at Harness. I live in Minnesota, like I said, and I'm thankful for this opportunity to speak with you today. So I stand before you today being lifted on the shoulders of many great people, especially from Chaos Native, who started this free virtual conference a few years ago. Now in its third year, we've reached a community of practitioners in the thousands across hundreds of organizations all over the world. And as you can see by the schedule and speaker list, our industry has come a long way since Chaos Monkey in 2010, and more personally, since 2016, when I had to Google what is Kubernetes, and that began my chaos engineering adventure. As you can see in many of the presentations today, our industry is maturing past chaos engineering is cool to chaos engineering is required to build reliable and resilient systems and businesses. The practice and discipline has even crossed into security testing, service level objective, observability validation, and more importantly, improving developer productivity. It's not just about injecting failure today, but it's about fixing things on purpose as well. Besides the great list of speakers, we have a breadth of industry best sponsors who not only have expertise in chaos engineering, but also building resilient engineering practices across an enterprise. Thank you to our Ferris wheel sponsors, Nagaro and Blameless. To their sponsorship. I'm looking forward to their presentations and workshops over the next 2 days as well. So in between sessions today, if you break over into the booth selection, there's 4 booths today. So Nagaro, Blameless, Harness, and Grafana and Kasich. So please enter in there for some great conversations. Also, I just was going to mention there's a lot of people, a lot of students here, people that have been laid off and impacted over this tech, the 3 session that's happening. So reach out, network. There's a lot of job opportunities out there, but more so mentors and people that can help you out. Lastly, I just want to say thank you for that. And what I want to do is introduce Adrian Hornsby from AWS. Adrian's work has been a point of reference over my career as a researcher in engineering, especially serverless testing. And he's going to tell us more about service engineering and serverless experience. So Adrian, for the
Thanks, Matt. And hi, everyone. It's such a pleasure to be here. I haven't done a conference in a while, actually, since early before COVID. So it's been quite interesting process to get to sessions, and hopefully this is brand new. So you can give back. So I'm Adrian. I'm a principal engineer.
Adrian, sorry to interrupt. I think we're having some feedback, of course. Let's see.
What's going on?
Let's see. Some people are a bunch of feedback. So just for that. And there's always chaos, so that's fun. I think this sounds better.
So all green from my side.
All right, go ahead. Thanks.
Okay, good. So I'm principal system engineer with AWS, focusing on reliability services and especially chaos engineering. And so I'm working with the AWS fault injection simulator team. So as I was saying, if you have any questions, feedback, just drop a message in the chat and I'll try to get to it at the end of the talk. And if I don't have time, just ask on Twitter or Mastodon and I'll do my best to answer. So since this is the first talk of the conference, and since we can't expect everybody to be an expert in chaos engineering quite yet, I'd like to take a minute or two to set the stage a little bit and explain briefly what chaos engineering is for the folks that don't necessarily know what chaos engineering is. So at its core, really, chaos engineering is the process of making an hypothesis about a particular system, stressing that system, and then observing how it responds. And then we make improvement on that system, right? And this is typically a continuous circle, right? So we make a bunch of different hypotheses and then we improve. And we do that to really prove or disprove our assumptions about our system capability to handle disruptive events. So chaos engineering really help us build resilient and performant application, and especially it help us uncover hidden issues like monitoring, observability, or alarms, or especially the lack of. And on top of that, chaos engineering gives us a way to practice our operational skills, and especially with the focus on improving time to recovery. And finally, it helps us build a culture of resilience. So since time to recovery is especially critical, I wanted to show you a little bit the latest IDC and Ponemon Institute estimate about the cost of downtime, right? And that's the average per hour for infrastructure downtime, and that's $100,000, right? So that's a lot. And of course, they are average, right? So it's not everyone in the same boat, but it's still pretty scary. And that means it puts a lot of pressure on businesses to avoid downtime. Now, think again about your previous outage and how long it lasted, and especially how fast it gets to 1 hour. And so does a 40-minute, but which is the time I have for this talk. So I should really get carried on. Okay, so now that we are on the same page, I want to tell you a little story. So a few years ago, I was on a call with a company and a bunch of engineers. And what really surprised me during that call is that the engineers I was talking to were extremely mature, and they were extremely mature for their relatively young age. Now, I'm not saying that young engineers usually sound immature, not at all, but these ones were really different. So usually when I talk to a company, I listen, I ask a lot of questions, and then I talk about my experience, what I've learned, and often I challenge their ideas. But that time, it was really different. They were challenging me and my ideas, and actually I learned a lot during that call. So they only had a few years of experience, and they were talking about problems and how to solve them in ways very senior engineer would. They understood in depth the concept of architecture, distributed system, resilience, that for me took years to understand. But they also displayed really good soft skills. And so intuition, empathy, embracing failure, patience, creativity, kindness, vulnerability. And it seemed they had it all and that they had seen it all. So since that call, I have had few like that, which is very interesting. And for me, it's always quite shocking. And so recently, I started to think about it a lot and what made those calls so special. And what really was interesting about the quality these engineers had is it's not some kind of magical thing that happens overnight. And when you grow old, it's actually qualities that need a lot of situational awareness, a lot of exposure to improve. And to have that exposure, you typically need a lot of time. And this combination of time and exposure is what we can call experience here. And on this call, with the seen it all companies, the engineers really seemed that they had hacked their ways into acquiring really great experience, but without having to spend a lot of time with it. So science tells us that we are much better at learning from negative experience, like failures. So what's interesting here is that if you think about it, that it seemed that these engineers, had probably seen a lot of outages, because for us engineers, we actually learn and get a lot better when we have outages, right? So those outages make us a lot better and a lot sharper. And if I look at myself, I can easily say that the most I've learned was typically following outages. For example, when I deleted a database in production, in fact, I did it twice, and I did plenty of other mistakes too. And it really is from those events that I learned a lot and I grew as an engineer. So what did this company do, like, to hack the space-time continuum? How did they get so much experience in such a short time? Well, it turns out they all had the one thing in common, and that's they had fully embraced chaos engineering. So instead of waiting and learn through painful, unplanned, and customer impacting event, excuse me, they actually control the narrative. And in the process, they found that the way to get the maturity and experience is really through doing a lot of those outages, right? And it didn't take them years, right? They could do this pretty fast. So it turns out chaos engineering is actually really good practice to accelerate learning, and not just the knowledge necessary to build and operate system, but also the skills to recover those systems from an outage. So in other words, we can say that chaos engineering is really a compression algorithm for experience. So in the past few years, like Matt said, chaos engineering has been getting a lot of attention. So while 5 or 6 years ago, or even 10 years ago, chaos engineering was more of an engineering marvel, right? Something that only a few could do. In the past couple of years, the discipline has really picked up. And my colleague Laurent, who is in the panel during the conference, tracked all those public information and put them into a GitHub that you can access if you want. And in there, you can see financial services are one of the industry that quickly ramped up with chaos engineering. So you have Ito Brazil, Capital One, JP Morgan Chase, Vanguard, Stripe, among the most well-known ones. And in the media and entertainment industry, you have Prime Video, Slack, Audible, and of course, Netflix. And telcos are also jumping on the train, like Twilio, Orange, and T-Mobile. And then transport airlines as well. Alaska Airline, Uber, Lyft, the hospitality, the gaming, the fashion, the ERP, and even the government. All of these are in some form or another embracing the practice of chaos engineering. And it all sounds great, really. But unfortunately, it's just a drop in the ocean. A lot of companies may have started their engineering journey, but many haven't. And the few that start often get stuck. So let's try to understand why. Roughly speaking, you can categorize testing into 5 different modes. So you have the ad hoc mode, game day, you can do testing in a CI/CD pipeline, you have canaries or A/B testing, and then continuous testing. There are a few exotic modes, but that's basically it. So ad hoc testing is typically really informal, pretty unstructured, and it's done randomly. And it's usually unplanned and does not follow any documentation and design technique. So it really relies on the experience of people, their intuition, and so forth. Then you have game days, and game days are really like fire drills. It's to practice and evaluate the team incident response capability, typically. And these are typically quite expensive because you gather the team together for a day, and it takes a lot of time and energy. And then you have CI/CD pipeline testing, and that's typically testing done in the early stage of the release pipeline, and to do something called testing everywhere, that is across the environment, the operating system, and the devices. Then you have canary testing, that's testing a new version of an application in parallel to the older one. And you do that by gradually sending a small percentage of traffic to the different version of the canary, and then you see how it behaves. And it's often called phased or incremental rollout as well. And then you have continuous testing, and that's really testing in the environment itself, typically in production. And that's the ultimate test of confidence. So for example, you continuously inject fault in a production environment. That's basically what Netflix did with their Chaos Monkeys back then. So what does it have to do with chaos engineering? Well, ideally, you want your chaos engineering journey to progress across these 5 different modes, because that's when you get the full benefit of it. And it may not be right for all the experiments. So some experiment might not be good for continuous or canary testing. But at least you should think about these 5 modes when you do an experiment and try to progress it across these 5 modes. And if you look at it today, most of us are stuck in the ad hoc and game day mode. So we slowly start to talk about chaos testing earlier in the development process. That's called shifting left. But even that is just the beginning. And I'm really glad to see there's so many talks about it at this conference. So it's really going to be cool to see that. But there's still a long road ahead to unleash the full potential of chaos engineering. So let's talk a little bit about the book. It's called Crossing the Chasm. It's by Jeffrey Moore. And I would say it's one of the greatest books on technology management, which happens to be my minor at the university. So what the book tells us is that the adoption of technology begins with the innovator and then moves slowly to the early adopters, the early majority, the late majority, and finally the laggards. In the book, he explains that innovators and early adopters are often driven by the fun of technology itself, and that they will happily do sacrifices just to be first. So these are the people that go and camp for days or weeks, when the new iPhone is being released. Now, typically the early majority wants to wait until they know that the technology actually offers improvement in productivity. So what is important to realize here is that there is this chasm. So this chasm between the early adopters and the early majority. So that means that once your product has been adopted by the innovators and the early adopters, you actually have to adapt the target market. And that means you may have to change the whole product concept, the positioning of the product, building even a different marketing strategy, choosing a different distribution channel, and even changing the price. And doing this changing is what is called crossing the chasm. What is interesting here is that this crossing the chasm theory is not just for the general public marketplace. It actually also applies for the diffusion of technology within a company. And it explains why some teams adopt new concepts and ideas before all the others, and why different teams within the same company may be totally different from one another. That's because that's why many companies are stuck in the chaos engineering chasm. So some teams are interested, they might even be very successful to start, but they find it hard to get the discipline stick as a standard practice within the broad organization. That's because the team that you are in maybe might be part of the innovator or the early adopters. And typically those teams love technologies. They love trying new things. And it's also because you strike gold and you find that within your team, you probably have some chaos champion that are willing to put up with sharp edges. But for the rest of the organization, it doesn't work. They need to be convinced about the improvement in the productivity before anything else. They just don't buy it blindly, so you have some convincing to do. So how do you climb out of that chasm? How do you spread that love that you have for chaos engineering to the rest of the organization? How do you help them get started? How do you convince them that what you do is important for the business? So in the rest of this talk, I'll discuss 5 ideas that I hope will help you climb out of the chasm and get unstuck. The first is understanding the what. Then I'll talk about setting goals. Then about getting started. Then about reinforcing mechanism, and then that anything is better than nothing. Let's start with the first one, which is understanding the why. In the book, Start with the Why, How Great Leaders Inspire Everyone to Take Action, Simon Sinek, who is the author, explain what it means to start with the why and how it can create true, lasting success for us and our businesses. So he argues that the decision that starts with why wins hearts and minds. And in the book, he presents the golden circle with 3 levels of decision making. The why, which is the core belief of the business. It's why the business exists in the first place. Then the how, this is how the business fulfills the core belief. Then the what, and that's what the company does to fulfill the core belief as well. Now, the author explains that the why helps us understand why we do what we do, and that we can achieve more if we remind ourselves to start everything what we do with first asking ourselves why we do it. So starting with the why is equally important with chaos engineering. When we try to convince others to start chaos engineering, most of the time we start with the what and the how, but rarely explain the why. That's because most of us are engineers. We are innovators, early adopters, and we think everyone else is like us, interested in the what, which is the technology itself. We think it's cool and we forget why we use it in the first place. And that's wrong. So to convince others to get started, you have to explain the why. You have to convince them about the improvement chaos engineering brings to the business before anything else. And breaking things, while it's cool, it's not one of them. So especially breaking thing is not great when you go and talk with a CTO or a CEO. He might just tell you, wait, you want to break things? Yeah, no, thank you. So it might sound silly like that, but making it crystal clear why you need chaos engineering helps us focus on doing the right things and also makes us more engaged with it. And it also helps our business leader buy into what we're trying to achieve. And like I hinted at the beginning of the talk, linking chaos engineering to the cost of downtime and how it can help reduce it speaks to the business. That's where the money is. Finally, understanding the why help us with one of the most important aspects of chaos engineering, which is goals. Once you understand the why, you can start setting your goals. And research has found that goal setting increases employee motivation and organizational commitment. It also affects the intensity of our actions and emotions. The more difficult the goal is, the more intense our effort will be in order to achieve that goal. So in the past 7 years that I've talked with customers about chaos engineering, setting goal is probably the most underrated needle mover. In fact, I would even say that not setting goal for the chaos engineering practice is the number one factor for getting stuck. How you can convince your organization to stay invested in chaos engineering, which is relatively expensive discipline, if you don't have goals. So the next question is, what sort of goals are we talking about here? Well, you can have plenty of different goals. Some focused on user experience, some focused on service discovery, some focused on adoption, some on experiment, and some on metrics, and so on and so forth. You can have team, organizational goals, company-wide goals, joint, shared. All of them are valid, but you just need to find what works for you, especially what aligns with your why. Now, I wanted to say it out loud. The most successful companies I've seen when it comes to chaos engineering have always had top-down goals. So goals taken by leaderships are, in my opinion, the best way to drive long-term chaos engineering commitments, especially when these leadership goals are tracked through monthly or quarterly business reviews. It helps keeps the momentum. On the other hand, the ones or the goals driven by teams on the ground and without leadership support often hit the wall. So find your goals, and by typically looking inside your organization, right? Is there an event or a capability that you need to get ready for? It doesn't have to be an amazing goal. It can just be a very tactical one. So let me give you some example, a few goals that we've taken around Amazon and AWS when it comes to chaos engineering. The first one is a configuration check goal. So very tactical goal. And in March 2020, Prime Video launched something called the Prime Video Profiles, which basically gives user recommendations, season progress, and a watch list. And it's a bunch of services that were built on Amazon EC2. So these services are part of a distributed system, and they call other internal AWS and Amazon services over the network. So testing the timeouts, the retry, verifying the circuit breaker configuration, all that stuff was deemed very critical. And confirming that the API timeouts would not exceed a particular limit became one of the goals. And so Prime Video went on to build Chaos Runner, an open source framework for injecting faults in service dependency, all at the same time when generating load against that service. In the process, they leveraged some of my scrappy SSM documents for injecting faults on EC2, but guess what? It got the job done. And as a result, timeouts, retries, and circuit breaker configuration were validated by running Chaos experiment, and we actually discovered bugs in the cache configuration. So that bug fix prevented the customer impacting failure from happening. Now the service, Chaos Runner, has evolved and now is leveraging FIS, but they got started by simply starting small. Today, Prime Video continues to take all sorts of goals. Many are related to upcoming live events, such as the English Premier League, the National Football League. And in her talk, Improving Business Resiliency, Olga Hall explains how these goals have helped Prime Video push forward their chaos engineering journey. So I really recommend all of you to go and check the talk after this conference, of course. And you can also take service recovery goals. So for example, the AWS Lambda team took a goal for their service to be able to evacuate an availability zone failure within 5 minutes. That was the goal. And with that goal, the Lambda team went on to developing automation that shift customer traffic from an affected zone to a healthy one, something that is called availability zone evacuation. So the Lambda team went to build tools to detect failures and perform this evacuation. And then they went with FIS to verify that their evacuation strategy worked as expected. So here, chaos engineering was used to verify recovery procedures. You can have user experience types of goal, and that's the Amazon search story here. So Amazon search is what powers the main Amazon.com page, right? It's the search bar. And they use chaos engineering extensively to be ready for Prime Day any day. And we're talking about millions of products here, and 300 million active users. So to give you a to give you a sense of scale here, during the last Prime Day, it's approximately 84,000 requests per second. And that's a lot of requests. What's interesting with the search team is that they've taken an approach to chaos engineering, which is quite unique. And you can call it user experience focused chaos engineering. And they use a goal that is framed within an SLO, a service level objective, and an error budget. So it's sort of contract between the user experience and the search. So here's an example of SLO. It's not the one that's actually used, but just to give you, just for the gist of it. So in a 28-day trailing window, we'll see 99.9% of requests with a latency of less than 1 second, and that's the SLO. So from that SLO, you can derive the error budget. So that means 99% of the requests with a latency of less than 1 second means that we have 0.1 that are greater than 1 second, and that's the budget. So every request that exceeds 1 second is consuming that budget. And eventually, it can consume, we run out of a budget. So how fast that budget is burned is called the burn rate. And since there's this 20-day training window, the oldest requests that are greater than a second eventually age out. So that means that if your burn rate is really fast, it can warn you, or is very abrupt, it can warn you of a sudden, really large change in the consumption of that service. So if the chaos experiment burn rate is too steep and you start running out of error budget, typically you want to abort the chaos experiment until the budget replenishes. So that SLA and the error budget here is a very customer-focused way to drive chaos engineering. And it works very well for the search team. Now, this is a more controversial one, but I've seen it work very well. So I want to share that with you. And that's using a resilience score to drive chaos engineering. So typically, a resilience score is calculated by awarding points to a service that adopts proven best practices. So that score can reflect different resiliency policies, alarms, standard operating procedures, some tests, even some different chaos experiments that are suggested for the organization. And that score can give service owner a way to track their effort to become more resilient. So a low score typically indicates that something needs attention and points the team to it. It's more about teaching the risk than it's about aggregating data across the different tools. And it can be very helpful as long as you understand the risk associated with metrics. Having a resilience score is counterproductive if you don't show what goes into it. So basically, you create a situation where a team has a high score with a false sense of positive. So those metrics can be hijacked. For example, when people replace the general idea of the goal or mission with the hard metric, when it becomes all about the metric. This is called surrogation. And you see that happen a lot when companies attach financial incentive to a metric. It's usually a mistake, as it makes people focus only on that metric and nothing else. So if you ever want to use a resilience score as a goal, don't attach it to a financial incentive. Make sure it's not the only metric, and especially attach it with multiple other metrics or goals. Now let's take a look at getting started. So if you've been trying to spread the love of chaos engineering in the rest of your organization, you've probably heard that one. How can we start? What hypothesis should I do? In fact, this is by far the most common questions I get. And while I used to take a deep look into the system and the architecture and the single point of failures and all that kind of stuff, now I only ask a couple of questions. And the first one I ask is, what are you worrying about? And to me, that's the most powerful question, because often if a team is worrying about something, it's intuition-based. And for me, it means it's serious. It's so serious, actually, that the question, what are you worrying about, is part of what we call operational readiness review at Amazon. And these are reviews we do before launching a new service. And if several team members worry about the same thing, then really rank it up. And then design experiments that address those concerns. So listening to intuition has never been a waste of time, and quite the opposite. But, there's always a but. Have you heard the saying, dogs not barking? So it's a reference to a Sherlock Holmes story called The Adventure of Silver Blaze. And in that story, at one point, the Inspector Gregory asked Holmes, is there any point to which you wish to draw my attention? And Holmes answered, to the curious incident of the dog in the nighttime. To which Gregory says, the dog did nothing in the nighttime. And Holmes famously answers, that was the curious incident. So the lesson of dogs not barking is to pay attention to what isn't there, not just what is. Absence is just as important as telling. Absence is just as important as presence. So the second question I ask is, what are you not worrying about? And that question, we tackle biases and overconfidence, such as, my system never failed, no need to test it. And actually, often turns out that the system did fail, but no one realized, because either there was not enough monitoring, or no alarms, or it just didn't work. Dogs not barking. Another way to get started is by first looking at the anatomy of an outage. And it looks something like that. So you first have the detection. Well, first you have the outage. Then you have time to detection. Then the evaluation phase, the response phase, the recovery phase, and eventually the confirmation phase. You can see there's a bit of fear after confirmation, because typically that's when people are worried if they're going to lose their jobs. But we're not going to talk about this today. But yeah, it's there. Now, if you remember my comment about the cost of outages, understanding and improving the timing of each phase is very critical. Oh, my connection is interrupted. I have a warning. Do you hear me? Hello? Matt? Hello? My connection is interrupted.
We hear you. I think everybody got that message, but
Okay.
it works. So you
Cool.
can continue. And just from a time check here, we're at 6 minutes after too. So
Okay, so I still have
9 minutes.
Okay, that's plenty enough. Cool.
All right, thanks.
So once you figure out the different phase out, you can really realize something, that being able to recover quickly from failure is more important than having the failure less often. And to recover quickly, you need to practice up. And recovery is not binary, right? Systems are built with hundreds of dependencies and services, and some are more critical than others. So imagine your company's business is to provide an email service for your customers. Critical functions are to receive and send emails, and the rest is good to have. So each service has some different criticality levels. And during an outage, understanding these levels really helps you prioritize what you should do. So take a moment to think about your application, and if you have very clear criticality definitions. And at the minimum, you need normal operation and minimal critical operation. And of course, you can have more, but that's the bare minimum. And then work out the different recovery plans for each mode, short to long term, and go verify them with Chaos Engineering. That's super critical. It will make a difference between a 30-minute outage and a 6-hour outage. And especially doing all that will help you reduce time to recover. So getting started is great, but how do we keep momentum? And the answer is really mechanism. One of the most important mechanisms we use is called an operational readiness review. And it's a list of questions that we go through to evaluate to evaluate the operational state of a service. And we do these ORR at service launch and repeat them regularly as the service grows. And it's for us to find the blind spots and especially identify high-risk issues. And we take them very seriously, right? If a principal engineer or a senior engineer is not signing off the ORR, the particular service or feature is simply not going to launch. And one of the questions in this ORR is, what is your game day plan? And for that question, the team needs to really enumerate the dependency of each component, their failure scenarios, and develop a comprehensive plan to go and verify them. And that's a very good way to enforce chaos engineering, if you ask me. I have pulled the plug on few of those launch and never been questioned about my judgment. And this is very peculiar to Amazon, of course, but it's not something that you cannot reproduce in your own company. Of course, you need to have the right culture. Right? So notice that the question, what is your game day play, gives a lot of room for interpretation. So we also have to have a good judgment here and know when to pull the plug or not. And then you can share these wins. And this seems simple ideas, but very important. And that's, sharing the love. And we do that by simply sharing an email across the organization, or we discuss that in our AWS weekly ops meeting. And that has the visibility across the whole company with the most senior leaders leading the show. And when we share win, we also share the details on how we got there. And typically a win leads to a lot of new leads with other teams to get them started. Right? So I've seen teams get started out of wins a lot, and that's a very good mechanism. And finally, I want to talk about anything is better than nothing. So humans are often obsessed with comparison and validation, right? And that's especially true for social media and true for technology as well. So when we read the blogs or hear at conferences stories about how people do chaos engineering, we only hear one side of the story, and that's often the successes, not the struggle. The truth is everyone struggles. And when it comes to chaos engineering, injecting fault in the system got to be one of the scariest things you have for an engineer. So when you read about X or Y doing chaos engineering in production, take it with a grain of salt, because it might make you feel inadequate. And even the great companies companies that you think are great struggle. Okay, not all the teams, not all the squads, all the organizations are equal. Some workloads are more chaos friendly than others. So what I'm trying to say is that you may not be as far behind as you think. An old slogan of the Lotto company said 100% of the winners tried. So trying your luck with chaos engineering is really more important than succeeding, because the people, the team, and the organization that get started are the only one that finish. Starting now means that it doesn't have to be perfect. Hacking your way is totally fine. Start with what you have, and the rest will follow. When Amazon started in 2001, Jesse Robbins was master of disaster, started by unplugging servers in data center. Over time, the program that he called the game day evolved and became more sophisticated. But it was almost 20 years ago, and we're still learning and improving today. When I first started with chaos engineering, there was no public tools available, and so we had to axe our way down the stack. Today, there's more tools from cloud providers, third party. None are perfect, maybe, but at least it'll help you get started. So the truth is we learn more from the process of pursuing excellence than from achieving it. And I can't think of any more critical skills to chaos engineering than the willingness to start. And the final thoughts, and hopefully I don't overrun too much, Matt. That's the last slide. Each system is really unique. So the lesson you learn from in one side of the organization might not apply everywhere. It takes three interconnecting elements to really successfully operate the technology we built. First, you need the right culture, you need great tools, and you need complete processes. Chaos engineering here is the technology in focus. So organizations need to develop their own unique ways. What is important to understand with this interconnectivity between culture, tool, and processes is you cannot expect to have a successful chaos engineering journey if you only focus on the tools, which is unfortunately a common mistake I see. You must nurture a culture and the process that supports your chaos engineering journey. And if you don't do that, you'll get stuck in the chasm, unable to move forward. So I hope I've given you some ideas to move forward in your chaos engineering journey. I'm really excited to listen to all the talks, and I'm sure I'll learn a lot. So thanks again for inviting me and let me share my thoughts with you. And don't hesitate to reach out to me. And if you want to chat, I'll be hanging out here, and you can reach out to me on Twitter, on Mastodon, or follow me on Medium as well. Anyway, thank you so much. And the floor is yours, Matt.
Yeah, no, great. Round of applause. You can't hear everybody, but hopefully you can hear me. But no, thanks so much. Really appreciate that. We have a bunch of questions in the Q&A. However,
Cool.
My technical difficulties earlier this morning, we don't have much time because we have some presentations rolling and the other thing. But what I offered, I copied all the questions and I can put them in our Chaos Carnival Slack channel, which I threw the invite in. And then we can thread our answers to that. Adrian, I know it's dinner time for you, but you know, today, tomorrow, you can also kind of answer people's questions with your expertise as well.
I'll hang out. I'll hang out in the Slack, and I'll go in the chat to see a little bit as well.
Yeah, and I'm getting a live feed from my coworker. We can go ahead with 3 questions.
Ooh, go for
you're
it.
good with that. So I'm just gonna look at the questions here quick. And all right, how about this one? What do you see about ChatGPT being utilized with chaos engineering?
That's a very good question. I actually haven't really studied ChatGPT in the context of chaos engineering, but I can see it's gonna more as a especially as a learning accelerator. So maybe I'm gonna have calls with companies that gonna be way more senior and principals after just a year or two of practice, which is which is great. Yeah, it's actually a very interesting question. I definitely need to poke ChatGPT with chaos engineering, but I'm pretty sure it's going to be interesting.
Yeah, I mean, for me, I work from home by myself, and I have 2 dogs that don't respond to me when I talk. So I often use ChatGPT just to like ask it questions for feedback. So it's like a little coworker, just it's a good validation. It's interesting. So definitely something to explore. We have another question here. Can't companies just use multiple servers in the cloud and then call it good and not expect any downtime?
Yeah, I mean, you can hope for things like this, but in the cloud, even at scales, and especially at scale, right? Everything fails all the time. So you can hope for the best or be prepared for the best. I think most people prefer to be prepared, but again, it depends on your business. If your business doesn't need to be 5 nines of availability, then by no means don't do chaos engineering. And that's what I refer to. Why are you doing chaos engineering? If your business doesn't need high availability or resilience, you have other things to do than go and tackle chaos engineering. Hi, doggy.
All right, and maybe the last question here: where would you start chaos engineering? Top-down approach or bottoms up?
I would go top down. Like as I said, for me, like the most successful companies I've seen and how I've seen things work as well in internally, it's by far top down. If you don't get leadership support, or if they don't understand why you're doing what you're doing, how are they going to prioritize your work and give you the head counts to and the leeway to do what you want to do? As I say, it's expensive to do chaos engineering. So my dog woke up as well. So yeah, I mean, top down by far. I'd say I'm not saying bottom up, can't work, but the chances of success is much better with top down.
Awesome. I love how our dogs are giving each other feedback here too.
Yeah.
Yeah, we'll end right there. I'll take a list of the questions, put them in that Slack thread, and we can all just kind of, everybody's invited to kind of like thread to the question just to build, us up in the community. And then there's some more presentations after this. So once I end the session here, those will open up for people to join. So I would love to see everybody in this session join those. And if you can't make it, we will have the recording eventually. But again, would love to see you all there and everything. So
Yeah.
thanks so
Thanks
much.
a lot. Thank you. Bye-bye.
All right. Bye, everybody. See you soon in the next session.